Everyone, today we will gonna discuss about completely randomized design. This is one of the single factor design, and now we'll be discussing about it. So coming to the next slide. So when we apply CRD, when the treatments are arranged randomly over the whole of previously set of experimental unit, the design is known as CRD. Not preferred on field experiments, mostly preferred in greenhouse and laboratory conditions. So CRD is the most simplest design in experimental designs, and it is mostly done in case of homogeneous experimental material. It is not used in field since field has heterogeneity in terms of fertility and other factors. So CRD is mostly done in homogeneous field, and homogeneous experimental material could be formed in greenhouse and laboratory conditions. Okay. So now description of the design. It is the simplest design to use. Design can be used when experimental units are essentially homogeneous. Because of the homogeneity requirement, it may be difficult to use this design. To use this design for field experiments. The CRD is best suited for experiments with a small number of treatments. Now, what are the advantages? It's a very flexible design. That is, number of applications may vary from treatment. So it is not having any kind of restriction in number of application as well as number of treatments. Here, all the experimental materials can be used without any wastage. Statistical analysis is simple as compared to other design. It provides a large number of degrees of freedom for the estimation of experimental work. Now, what are the disadvantages? It is less accurate than other design. There are other more single factor experiments like RBD, LSD. It is less accurate than that in comparison to other designs. Usually, the least efficient designs, unless experimental units are homogeneous, not suited for a large number of treatments. So, whenever we came across large number of treatments, it may not be suitable. What is the procedure? How we will be applying this in a certain kind of treatments with a certain kind of experimental units? Treatments are assigned to experimental units completely at random. Every experimental unit has the same probability of receiving any treatment. Randomization is performed using a random number table, computer program, etc. Layout of CRD. The CRD is very simple to plan. The treatments are randomly allotted to the plex boards. We can use random number table for allotment of treatments to a plot. Now, how will be using the random number table? This is a kind of method to draw a random sample from a population. Okay, we can use this method for a small number of sample. So these are some of the steps to be followed while using the random number table. Now, how the allocation of the treatments to this particular units should be in randomly. The treatments will be allocated in a sharpened way. As you can see, it's a plot size of 20 experimental unit. Here first unit 1 2 3 4 5, it's a ordered, then again it is 10 9 8 7 6, like this way in a serpent way. So numbers are serially starting with serpentine manner. Now, how will be ranking the treatments? So if we consider 4 application of each treatment, then and we have to rank them in terms of random number. The lowest number will be given 1, the highest number will be given the highest respective rank. Okay, then in the allocation of the first treatment, then we'll be ranking them. Say this T1 has been random number has been allocated as 18 4 10 and 9, then it will be placed in 18 4, 18th unit, 4th unit and 9th unit, 10th unit respectively. Similarly, the other treatment also. So the random numbers are written in order, are ranked. The lowest number randomly is given as, and the highest number is allotted to the largest number. The final layout has been given, prepared like this way. Now this is the model that has been followed in CRD. That is, we can say it's a one-way ANOVA model where mu is the general mean effect, small ti is the treatment effect, and this is the chance effect. So this is the model. It is similar to our one-way ANOVA model. And here also we have to calculate certain types of calculations like correction factor, that is the formula is gain total square divided by small n, then total sums of square, treatment sums of square, error sums of square. Here we are calculating three types of variations, means two types of variation, and total sums of square will be calculated from them only. So this is the variation due to within the treatments and variation due to between the treatments. So ANOVA table for CRD treatment, T treatments is going like this, where sources of variations are due to treatment and due to error. Then our degrees of freedom for treatment is T minus 1 and for error is N minus T, where N is the number of observations. Then we can calculate the sums of square, then treatment sums of square, error sums of square. Then dividing with respective degrees of freedom, we will be calculating the mean sums of square, and finally the F value. That this F value will be the calculated F value. Then we have to compare with the tabulated F value, either to reject the null hypothesis or to accept the null hypothesis. And further we can go for, if the statistics become if the test becomes significant, then we can calculate the critical difference value also, and critical difference value will help us to know what are the two treatments that are significantly different or they are not significantly different. And in critical difference formula we have the T value, T test. From T value we will be obtaining it with certain kind of error degrees of freedom. And if SC of D, standard error of D, there are two formulas, one for equal number of application and one for different number of application. So I hope this is a short lecture regarding CRD, and in the coming lectures we'll be discussing about RBD, LSD, etc. So thank you.